Welcome to the DIY Honda Garage channel. The DTC P2565 refers to a high-voltage condition in the turbocharger wastegate control actuator position sensor circuit. This error indicates a problem with the electrical signals sent from the turbocharger's actuator position sensor, which is crucial for proper turbocharger operation. The turbocharger plays a vital role in enhancing engine performance by forcing more air into the combustion chamber, thus increasing power output and efficiency. The actuator position sensor is located within the turbocharger assembly, and its proper functioning is essential for optimizing boost pressure during operations. A high voltage in the circuit can lead to erratic behavior of the turbocharger system, affecting overall vehicle performance. Therefore, timely diagnosis and repairs are essential to ensure the turbocharger operates within its designed parameters, maintaining vehicle performance and emission standards. DTC P2565 signifies high voltage in the turbocharger wastegate control actuator position sensor circuit. This issue can severely impact the functionality of the turbocharger, which aids in improving engine airflow and power delivery. The actuator position sensor, located in the turbocharger assembly, monitors the position of the wastegate. It sends signals to the engine control module, ECM, to adjust the turbo's boost level accordingly. High voltage in this circuit suggests a possible electrical malfunction or connection issue, which could lead to an inconsistent boost pressure being delivered. Such inconsistencies might result in reduced engine performance or increased emissions, making it essential to address this error promptly. Several potential causes could lead to the P2565 code, each requiring careful investigation. First and foremost, poor electrical connections can significantly affect the signals sent from the actuator position sensor to the ECM. These connections may corrode or become loose over time, especially at critical junctions such as the turbocharger and powertrain control module, PCM. Loose terminals can also contribute to erratic voltage readings. Lastly, if the turbocharger itself is defective or malfunctioning, it may generate higher than expected voltage signals, triggering this DTC. Thus, confirming the integrity of these components is vital for effective troubleshooting and resolution of the high voltage issue in the circuit. The symptoms accompanying DTC P2565 can vary, but typically include noticeable impacts on engine performance. Drivers may experience reduced power output as erratic boost pressure affects the engine's airflow, hindering acceleration and overall drivability. Moreover, the engine may become less responsive, resulting in sluggish performance, particularly during acceleration. Another key symptom to watch for is the illumination of the malfunction indicator light, MIL, on the dashboard, alerting the driver to a system irregularity. If left unaddressed, these performance issues may worsen, leading to further complications within the engine management system. Recognizing these symptoms early on can help in promptly diagnosing and repairing the underlying cause of the P2565 code. The first step in troubleshooting DTC P2565 involves initial verification of the problem. Start by turning the vehicle to the on mode. This powers up the necessary systems for diagnostics. Next, utilize the Honda Diagnostics System, HDS, to measure the EWG electronic wastegate voltage from the lift sensor. Ideally, this voltage should read 4.87 volts or higher. If the voltage measurements align with this threshold, proceed to the next step in troubleshooting. However, if the values do not match, it suggests possible intermittent failures or system issues. It's imperative to examine for poor connections or loose terminals, especially at both the turbocharger and the PCM. as these could be the root of inconsistent voltages affecting the wastegate actuator sensor functionality. In this step, you will start by turning the vehicle to the off or lock mode, securing the system before adjustments. Next, disconnect the Turbocharger 5P connector to isolate the sensor circuit for testing. After disconnecting, you'll connect terminals A and B with a jumper wire. Terminal A corresponds to female terminal number 3, and terminal B to female terminal number 4 on the Turbocharger 5P connector. Once the jumper connections are made, turn the vehicle to the on mode again. Again, use the HDS to check the EWG voltage from the lift sensor. The voltage should still read at least 4.87 volts. If it does, you can confidently proceed to assess the next areas. Otherwise, if the parameters do not match, it indicates the need for turbocharger replacement. Step 3 focuses on determining the potential failure area associated with the SG2 line or other related circuits. Begin by turning the vehicle back to the off or lock mode, ensuring safety before making any changes. Afterward, remove the jumper wire from the Turbocharger 5P connector to restore it to its original state. Once done, turn the vehicle to the on mode again to power the system. In this step, you need to measure the voltage between test points 1 and 2. Test point 1 is located at female terminal number 2 on the Turbocharger 5P connector, while test point 2 is at female terminal number 3. Verify the reading. About 5.0 volts indicates that the circuit is functioning correctly. If the voltage differs, move on to the open wire check for further investigation into the line connectivity. For step 4, you will focus on assessing the open wire associated with the SG2 line. Begin by turning the vehicle to the off or lock mode once again for safety. Following this, you'll jump the SCS, System Connector Short Line, using the HDS and allow a minimum of 1 minute for the systems to stabilize. After the designated waiting period, disconnect the PCM, Powertrain Control Module, Connector E, which contains 80 pins. With the PCM disconnected, check for continuity between test points 1 and 2. The first test point is female terminal number 3 on the Turbocharger 5P connector, and the second is terminal number 78 on the PCM Connector E. If there is continuity present, it indicates that the SG2 wire is intact. If not, further inspection into the wiring between the turbocharger and the PCM is necessary to identify any issues. The final troubleshooting step involves examining the DC-WGL line for potential issues. Again, ensure the vehicle is in the off or lock mode before proceeding. Jump the SCS line with the HDS and wait for more than 1 minute to allow the systems to respond appropriately to the diagnostic input. After this, disconnect the PCM Connector E, which contains 80 pins. Similar to the previous step, check continuity between test points 1 and 2. Test point 1 is female terminal number 4 on the Turbocharger 5P connector, and test point 2 is terminal number 60 on the PCM Connector E. If the continuity test shows that the DC-WGL wire is intact, it suggests that the circuit is functioning properly. However, if continuity is absent, it confirms an open in the DC-WGL wire, requiring immediate repair between the PCM and the turbocharger. After completing all repairs and troubleshooting steps related to DTC P2565, it's essential to conduct a final verification to ensure everything has been addressed properly. Begin by rechecking voltage readings from the EWG voltage and confirming that they now align with the expected thresholds. Secure any connections previously disturbed during the diagnostics process. Testing the vehicle under typical driving conditions will allow you to observe the engine's performance and response to acceleration. If the check engine light has remained off, and performance issues have been resolved, you can be confident that the repairs are successful. This verification step is critical to ensure that the issue does not reoccur and that the turbocharger system is fully operational. To prevent the recurrence of DTC P2565 or similar issues related to the turbocharger wastegate control actuator, implementing a preventive maintenance strategy is crucial. Regularly inspect all electrical connections associated with the turbocharger to ensure they are secure and free from corrosion. Maintaining cleanliness in the turbocharger system can also contribute significantly to its longevity. Dirt and debris can impede sensor functionality. Additionally, routinely check the wiring for any signs of damage, wear, or chafing that could lead to intermittent failures. Educating yourself and staying aware of any manufacturer guidelines related to engine performance and turbocharger care can further help in preserving the system's integrity. Proactive maintenance is an economical approach to avoid major failures and associated costs in the long run. In summary, DTC P2565 indicates a high voltage condition in the turbocharger wastegate control actuator position sensor circuit, significantly impacting engine performance. Proper diagnostics involve checking voltage readings, verifying connections, and possibly addressing wiring issues. Understanding the roles of components, such as the turbocharger and its actuator sensor, is essential for effective troubleshooting and repair. Regular preventive maintenance can help avoid future occurrences of similar codes and ensure the vehicle operates at peak efficiency. By adhering to these guidelines, you support the longevity of your Honda Accord while also enhancing its overall performance and reliability. Please like and subscribe to the channel. See you next time!